Hello everyone. Today I'm going to do a presentation on my final year project. So my project name is Generating Adversarial Yet Inconspicuous Patches with a Single Image, and my supervisor is Zhao Jun in SCSE NTU. So the background of this project is very simple. So despite the popularity of deep learning, it has been shown susceptible to the adversarial patches, where the exotic patches patterns can successfully fool the whole deep neural network. But the adversarial patches are generated by the region-confined crafty noisy patterns, and which will be then attached on the natural input. So the motivation of this project can be divided into two parts. So firstly, the existing adversarial patches are very noticeable to human observers because of their exotic appearance, and you can see from these three examples. And if such attack can be easily detected by human, the text will fail in a real-world practice by a prior human check. And secondly, the existing patch methods require large-scale datasets or large-scale GPU clusters for training, which are computationally expensive and time-consuming. And how to explore such adversarial patches under low data resources has become a very, very intriguing topic. So our research goals are very clear. So firstly, how do we generate adversarial yet inconspicuous patches? And motivation two is how to generate such patches under low data resources. So these goals are not easy because the inconspicuous appearance can harm the attacking capability of adversarial patches in general. So our approach can be summarized in an overview picture. So given a target image, we will first generate a GradCam explainability map with a target to capture the model's sensitivity and decide the patch location. And then we deploy a series of the cross-to-find GAN architecture. And in every skill of the GAN architecture, we execute the adversarial training for generators and discriminators. And our goal of these cross-to-find GANs are very clear. We are going to generate the adversarial patches, and the discriminators will attempt to distinguish the synthetic samples from the real generated images. So since our approach requires the generated patches to be consistent with the original image, the input of a discriminator, as you can see, is the surrounding context with the intermediate patches placed right at the center of the context. By this attachment, the background information will be generally and gradually encoded to the generator. And this part is our crafted laws for generators and discriminators. For details, you can refer to the FYP report. And these are the examples of the adversarial patches. Please note that at the first glance, most of the images looks quite natural. But if you can look detailedly, will see that this part of the zebra is kind of exotic. And on the car screen, car's front screen, you can also see a noise patch. And on the right lower corner of the cake, you can also notice a patch. And this kind of the inconspicuous attacks will make the whole images being wrongly classified by the deep neural networks. And these are just a few examples of the adversarial patches generated by our approach. And these are the overall summation of the experiment result on the success rate of our attack. And under this form, you can notice that the statistics indicates that our approach has very strong attacking capabilities in the white box setting and also in the black box setting, as you see these numerical values are not very low. And we also to do a silencer detection proposed by Soto in 2010 for adversarial patches, because our motivation is to generate inconspicuous patches. And we can observe that our approaches compared to the Google patch approach, this column, and the PSCAN approach, this column, this is AIP is our approach. And you can see that our approach well reserves the semantic saliency and the visual consistency compared to the other approaches, which can be very easily detected by the synergy detection. But if you see our approach, our patch is not that conspicuous under the synergy detection, and all the other examples states the same situation. So we also do a human evaluation to further confirm our motivation. So we hire 100 volunteers at least of the undergraduate education level in NTU Singapore to do a series of the user tests. So this table is to we ask the users to label out all the images in which the users think there are adversarial patches attached. And in this table, we ask the user to rank the images according to their natural looking levels. And you can see that although our approach cannot hit the natural image, our approach, which is AIP, can significantly outperforms than the existing approaches like Google Patch and PScan. And for table 3 is stating the same. Our approach AIP is quite close to the natural images, and our indicators is much better than the Google Patch and PScan. So we also conduct the experiment on the real world situation. So our approach shows that our digital approach still has some attacking effectiveness of the in a real world settings. And among 168 photos, there are 60 photos that successfully fooled the classifier to make the road sign unrecognized. So consider our approach is designed and developed in digital settings. We see that it remains very intriguing how to build stronger yet inconspicuous attacks with limited real-world data in the physical attack settings. So discussions can be conducted. So what can be improved in this work? So firstly, of course, the transferability among different test samples, and we can craft it, this approach to be more stronger in the real-world settings, and we should add more baselines for the inconspicuous attacks to compare the performance of our approach, and we can try that whether our approach is effective under the patch defense methods, and we can develop some interpretation tools for the GAN generators and GAN discriminators. So to summarize, we still need to consider how to deal with the adversarial patches, inconspicuousness, and the maliciousness. So in conclusion, in this paper, we propose an approach of the GAN-based adversarial patches trained with only one image to generate adversarial patches. So different from the existing works, we consider consistencies between the patches and the original images to evade detection from observers. Our approach employs a multi-skills of generators with discriminators to generate patches in a close-to-fun way. And to equip our approach with stronger academic ability, we consider the perceptual sensitivity of victim models by developing model explainative mechanism. And that's all about my FYP project. Thank you for listening.